Hello everyone, let us have a discussion on gradient of a scalar. Consider a scalar function said to be distributed on a three-dimensional space. It may be Cartesian or it may be cylindrical or it may be in spherical coordinate system, where I have taken here a scalar function which is said to be distributed on Cartesian coordinate system. You know the del operator is given by dou by dou x ax plus dou by dou y ay plus dou by dou z az. It's a vector operator. Now we apply this del operator on w, which is gradient of scalar del w is equal to a vector quantity, because del w gives me dou by dou x of w into ax. Look at it, ax is available in the expression, dou by dou y into ay, but when it is operated on w, dou by dou y of w into ay. Similarly, dou by dou z of w into az is the formula. Similar to Cartesian coordinate system, if the scalar function is defined on cylindrical coordinate system or in spherical coordinate system, in cylindrical coordinate system it is computed as dou by dou rho of w into a rho. Similarly, 1 by rho into dou by dou phi of w into a phi plus 1 by dou by dou z of w into az. Since the phi component is considered to be an arc, now 1 by rho is considered to be the normalization factor. So it becomes 1 by rho into dou by dou phi of w into a phi. Similarly, del w in spherical coordinate system is given by dou by dou r of ar, dou by dou r w into ar plus dou by dou theta of w into a theta, but it is accompanied by 1 by r into dou by dou theta of w into a theta. Similarly, 1 by r sin theta multiplied by dou by dou phi of w into a phi. So gradient is computed in Cartesian, cylindrical and spherical coordinate system in this way. These three expressions are essential. They are supposed to be memorized. Now let me look at the properties. The maximum rate of change of any scalar quantity per unit distance in any three-dimensional area is given like this, is given by gradient of a scalar. Similarly, the direction of maximum rate of change of w, is specified by the gradient. So by direct gradient does not only gives you the maximum rate of change of w per unit distance, also it specifies direction of maximum rate of change of w, and del w at any point is perpendicular to the constant surface over which the scalar function is said to be distributed. Okay, and directional derivative of w along the unit vector is identified. Any arbitrary unit vector is del w is projected onto the unit vector del w dot, right, a bar. Similarly, if you consider the scalar functions w of x comma y comma z and u of x comma y comma z, then del of u plus w gives me del u plus del w. Similarly, del of uw is equal to u into del w plus w into del v. Sorry, it should be del u into del w. Similarly, w into gradient of u. Similar to this one, del of u by w can be considered as w into del u minus u into gradient of w divided by w square. So these are the properties of gradient. Based on these properties, we can solve some problems. Let me find out the gradient of a scalar. The scalar quantity is x square plus y square plus z square at a point. The point is given by 1 comma 5 comma minus 2. Solution: how to obtain this gradient? Del t. Did you notice that this is a scalar function? Del t. What is the formula? In Cartesian coordinate system, dou by dou x t into ax plus dou by dou y of t into ay plus dou by dou z of t into az. So if you take the function and differentiate with respect to x alone, of course the second and third operation parts will become zeros. That is, if you look at the first component, it will become 2x plus y square plus, sorry, this component will become 0, no? I'm sorry, 2x into ax plus, if you look at the second component, 2y into ay plus 2z into az. So if you calculate del t at any point p whose coordinates are given by 1, 5, minus 2, you can just take x is equal to 1, y is equal to 5 and z is equal to minus 2 and substitute in this function to find out what is del t at a point p can be computed. Similarly, we can calculate the gradient of a quantity which is specified as e power minus z sine 2x cos hy. Gradient of an operator v, the gradient of a scalar quantity v will be dou v by dou x ax plus dou v by dou y ay plus dou v by dou z az. So when we differentiate, for example, v with respect to x, we found out that the one and only quantity which involves x will be sine 2x. So the remaining parts, e power minus z, cos hy, will all be treated as constant as far as x is concerned because it's a partial derivative. So the remaining part will be 2 into cos 2x. Okay. Similarly, dou v by dou y, which gives me dou by dou y of e power minus z sine 2x into cos hy. As far as y is concerned, e power minus z is treated to be constant and sine 2x will also be constant. The one and only parameter which will be differentiated this time will be sine hy alone, whereas rate of change of v with respect to z will be simply minus 1 into e power minus z, whereas sine 2x and cos hy are treated as constants. So we can calculate the gradient of a scalar function, maybe del v is equal to 2 e power minus z as a common parameter, or let me first of all substitute cos 2x cos hy ax component plus e power minus z sine 2x, whereas the one and only parameter that got differentiated is cos hy, so it becomes sine hy, and ay, the last component is e power minus z into sine 2x cos hy yes az. So using this you can calculate. Similar to this one, u is equal to, for example, rho squared z cos 2 phi. From the definition itself, I can understand that there are components, so I can calculate del u will be dou u by dou rho a rho plus 1 by rho into dou u by dou phi a phi plus dou u by dou z into az. So when we differentiate it, this will become 2 rho z cos 2 phi as such a rho. The next component will be 1 by rho is already present, rho squared will not be differentiated, whereas you have only z. So you will find out that it is equal to z is also treated as constant, whereas cos 2 phi when it is differentiated is minus 2 into sine 2 phi, and a phi is the unit vector, and at last you can see the component rho squared cos 2 phi a az will be there. Okay, similar to this one, I can ask you to find out the gradient of a quantity which is defined in a spherical coordinate system with the 10r sine square theta cos phi. How to calculate it? Can you just recall and find out? So when we compute del w, dou w by dou r ar plus 1 by r into dou w by dou theta multiplied by a theta, last component will be 1 by r sine theta dou w by dou phi a phi. So when you compute this, it will become, the first one will be simply with respect to r, so it is 10 sine square theta cos phi as such, only r is differentiated and it is 1, ar is the first component. The second one will be 1 by r into, already available, 10r is not differentiated, because this is to be differentiated only with respect to 10r cos phi, even to be treated as constants, whereas the only one component getting differentiated is sin square theta, so it will become 2 sin theta cos theta a theta. The last expression is, yes, 1 by r sin theta is there in the formula, multiplied by dou w by dou phi, which gives me 10r sin square theta multiplied by minus sin phi, whereas a phi will be there. Okay, I hope you would have got a clear picture about gradient operation on a scalar function. Thank you.